okay? Because if you can't get the basic curves, when we do a big shift with like a B that's not 1, it's going to be a little bit more difficult. So is everybody okay with this?
Yeah.
I used their answer sheet. They had all different colors. I really like their answer sheet for this one. Excuse me. Okay. Let's see what else we got here. I don't know how to get rid of this thing over here, so.
Okay. When the period is 2 pi over 3, how do you do that?
Okay, so what is 2 pi over 3 in degrees? So 360 divided by what? 360 divided by 3 is how many degrees? 120. So okay, think in degrees for a second. So 120, and you need 4 quadrants. So what's 120 divided by 4? 30. So you're going to go every 30 to make a quadrant. 4 30s give you 120. So start like this, easiest way. Here's your 180. Here's your 90. Okay? So you have to go to 120. Build these into 90 to 30s. Just break these down into 30s, wherever this one happens to be. I don't know where their things are, but start like this. Here's your 90, 180, 270, 360. Break these all into 30s, because don't you have to go to 120? Every 30 you have to build one? So now, start your pattern here. So if this is my sign, 0, 1, 0, -1, 0. Isn't that to 120? That's 1. Then do it again. 0, 1, 0, -1, 0. That's your second cycle.
I got it.
So the whole key to this is your increments. Olivia?
You just told me what the midlines for 3 say.
The midlines for 3. This is y equals 1.
4. I mean, like for question 3.
Oh, for question 3, I'm sorry. This, because this shifted it up 1, your line went from y equals 0, they added 1 to y equals 1. They shifted it down, it went to y equals -1. They shifted it up, it went to y equals 1/2. I'm sorry. I don't know if I can't make this bigger.
No, it's okay. She just couldn't see the value right there.
I probably could make it. Better?
Wow.
There it goes. Okay, better.
Wonderful.
Okay, so let's just get rid of this ink. Okay, sorry about that. All right, so is everybody okay with this? The key, guys, the key to this is your increments. And if you put this on the calculator, the same thing. You have to make your scale, your delta scale, match your increments. And you have to make your increments in your table be the same thing. Otherwise, you'll never be able to go from your calculator to your paper. I'd like you to be able to do this without your calculator right now.
I'd get the rainbow for 4.
For 4? Which one are you asking me?
One that the curve.
This curve here? This is probably a half a cycle, right? So which one had the half? Right there. Half a curve in 2 pi. And see, their amplitude went up to 2. Their amplitude on this one went to 2. But this says, my frequency says you only get a half of a curve, a half of a cycle, in 2 pi. So here's your half of your sine curve here. Then another 2 pi would give me the other half of my sine curve. So my period has to be 4 pi. I mean, my full cycle has to be 4 pi, my period. And why don't they have period as?
Cosine 1. The 2 cosine x plus 1.
I think their period is off. This
It
should
is.
say 4 pi.
Yeah.
That should
But I
say
was
4 pi.
confused Because for y3 on number 4, it says 2 cosine x plus 1.
Uh-huh.
Why?
Your period is 1. I mean, your frequency is 1. So
Yeah,
your
no,
period
yeah.
is 2 pi.
So what I'm confused about is why does their cosine go down?
Why does it go down?
Yeah.
Y3.
Oh wait, never mind. I get it. I'm sorry. I was being dumb. I got it. Never mind. Don't worry about it.
You have
I'll
it?
just confuse everybody.
Okay.
I was thinking stupidly.
Okay.
I'm
All
sorry.
right. Nope, you're fine. You're fine. Okay. And did anybody try the tangent? Okay, your tangent, and we're going to work on your tangent separately, but just in case you tried it, your tangent on your unit circle, just in case you remembered it, I didn't take it out of the sheet. I can't edit your PDF, so I just left it there. But your tangent is y over x. So anytime you divide by a 0, it's undefined. So wherever your x is 0, here and here, you can't divide by 0. So these are where your asymptotes come in. So your tangent has a nice little curve, has a nice little system of curves. It goes like this, then it has an asymptote like this. If you notice the period from here to here, your period is 180. It doesn't have an amplitude. The amplitude they say is 1, but it doesn't really have an amplitude. Your curve is endless. So you're in the same, your period here is every 180 degrees because you can only do this much or this much before you are undefined. So if you kind of look at your circle, doesn't it look like half a circle till you're undefined? There's your period. And we're going to spend a lot more time with tangent.
Okay.
So if you didn't get this, I'm not concerned. I just left it in there and I said if you want to challenge. Mathbits added a whole new thing to theirs, so it's really kind of nice. All right, so let's, guys, come on, pull this together here. Let's take a look at this.
40%.
All right, so you tell me if you had any problems with it.
Oh no, wait.
The concept of just graphing in the positive section is just making life a little bit easier because most of your quadrants will always start in 1 because that's where your positive starts, and you rotate around your circle from quadrant 1 to 4. So, you know, a lot of times they just have you graph within this time, within this window frame.
Because these graphs were really weird and hard to graph on. Like yours are shorter and ours are like this long.
Yours are
It's like-
longer?
It's like, and like there was a bunch of ticks in between each, like pi over 2 and then 3 pi, so it was like really weird to graph.
Let me see what this is.
I'm confused about the cosine one. Why?
I mean, it has them fine, mine just looks really weird.
Yeah, but yours is a little bit better because what did they increment yours by? What are your little six incremented by 30s? So that's going to help you.
I don't know, I think it's like,
Well, yours are incremented with tick marks by 30s. Guys, come on. Yours go like this. So they just incremented it by 30 degrees in here, or pi over 6, so that you get every 30 degrees. What's going to help you is when you change your frequency. Are we okay with these two? This one took a vertical shift, and be ready to say, vertical shift, down 1 unit. You didn't have to say, but just be aware of your transformations. This, we changed your amplitude, so vertical stretch, factor of 3. Number 4. So number 4 says my frequency is 1/2. That means I have half of a curve in 2 pi. So now, half of a curve in 2 pi. What's the period? How long to complete one full curve if I do half in 2 pi? 4 pi. So it's going to take me 4 pi to complete one full cycle. How many quadrants do we go through? On a unit circle, how many quadrants? 4. So if I take my period and divide it by 4, every pi is where my cycle goes. So I start at the 0, then at the pi I'm a 1, then at the 2 pi I'm a 0, then at the 3 pi I'm a -1, then at the 4 pi I'm a 0. Complete cycle. Okay, but they only ask you to go from here to 2 pi. I think this was a good concept to do because you saw exactly this is only a half in 2 pi. The cosine ones are different. They start the other way.
Because I always go up first because of sine. like sine starts at like 0 and then goes up to 1. The cosine starts at
At
1,
1.
and I always forget to go down back to 0. I just go up to 2.
Oh, okay. So before you started, just start like this. Just put that out there. Then do this. Watch. Here's how easy this is. Times 1/2. 1/2, 0, negative 1/2, 0, 1. Then what am I doing to this? Adding 1. Add 1. Add 1 to everybody. So if I add 1, I'm now 1/2, 3/2. Add 1. Add 1 to here. Add 1 to here. Add 1 to here. Oops, this was a half. 3/2. Okay, there's your cycle. 3/2, 1, 1/2, 1, 3/2. There's your whole cycle. Don't even think about it. Just follow the same pattern every time you do these. And then you just have to follow through. They gave you your frequency of 1. So it's still going 0, 90, 180, 270, 360, 0, pi over 2, 3 pi over 2, 2 pi. It's still going the same cycle. Questions? Everybody can do this. Okay, cosine. This just said I need 2 cycles in 2 pi. This is where your 30s come in handy too. Well, not for this one, but. So when I'm doing this, if I need to have 2 complete cycles, think it out logically. In 2 pi, this is what you say to yourself. How long to complete 1 cycle? If I need to have 2 complete cycles in 360, how long to complete 1 cycle? 180. Don't you say 360 divided by 2? 2 pi divided by 2. There's your period. So now watch. Go like this, guys. Here's your pi. How many quadrants do you have to go through for cosine? You have to go through 4 quadrants. So break this into 4 quadrants. Take half, then take half of each one of these. This is pi over 4. This is at pi over 4. So now I start. I'm at the 0, and they didn't change anything else. So my cycle, 1, 0, negative 1, 0, 1. That's 1. 1, 0, negative 1, 0, 1. That's 2. Good? Tell me if it's not. All right. Here's some shifts over here. Well, we got a couple of shifts. Okay, we shifted your cosine. We shifted it pi to the right. So, technically, I start at pi now. Did that change the frequency? No. So, technically, I'm going to start at pi. Start at pi and go to 3 pi. So right here, isn't that where your cosine curve would have started? Right? Nothing else was changed. So 1, 0, negative 1, 0, 1. I'd be up there. So I ran out of room. So I just worked backwards. What comes before this? Just drop it down. They gave you one little window to work in, but you could still work the whole thing out as if you were going from pi to 3 pi, and it just worked itself backwards. What part confused you? Tell me. Okay, so where?
Why is it going up if it's cosine?
Why is it going?
Cosine only goes down.
Cosine, no, I didn't shift it. We shifted it to the right, but there's no shifts up or down. But watch. Where am I going to start? Pi. So block this part off. Start right here at pi. That's my regular cosine curve, isn't it? 1, 0, negative 1, 0, 1. Wouldn't that be my regular cosine curve? And isn't this continuous? Does it ever really end? No. So now I got this blank space over here. I have to still use this. So there, just bring it back down. It's kind of like, it's almost like symmetric over there to the crest. It's a lot to take in. You did shifts last year too. And, granted it was over a year ago. Probably you did a trig this time last year. And I realized you've had a whole lot of math in between. Okay, how about this guy? We've got a couple of things going on. We have an amplitude change. What does this negative do? What is our amplitude?
2.
2. It's always absolute value. What does this negative do? Reflect over the x-axis. And what does this 2 mean to me? Frequency. So if my frequency is 2, what's my period? Pi. So now, every pi, I need to complete one full cycle. So I start like this. My sine curve says 0, 1, 0, negative 1, 0. Watch how simple this is. Just multiply everything by negative 2. 0, negative 2, 0. A negative times a negative, positive, 0. So if I have to complete here, I go through 4 quadrants. Make me 4 equal sections. Cut it in half, cut it in half. So here's my cycle right here. I hope you're watching. 0, negative 2, 0, 2, 0. There's your cycle. Do it again. 0, negative 2, 0, 2, 0. There's your graph. Good? Okay, so you have a couple of things going on. Now, I find it easiest to work with my cycle of 0, 1, 0, negative 1, 0, and multiply it whatever this happens to be in front. And then if there's a shift, that's a plus 1, minus 2, then I take whatever was left over and I do a minus 2, plus 1, and I know exactly where my points go. Or if it helps you, do your basic sine curve first. I would do this first. If you just want to not do the negative 2 yet, here's my basic sine curve with the thing of 2, with the frequency of 2. There's my basic sine curve. I'm going to reflect, so I'm going to start down, and I'm going to go amplify it by 2. So instead of going to 1, I'm going to reverse, come down to negative 2. Instead of being negative 1, I'm going to go up times 2. You could do it that way too if that helps you. Try to be able to get that to your paper. These guys, we took a period of 3. So what did this tell me? What does that 3 mean?
There's 3 cycles in 2 pi.
Good. 3 complete cycles in 2 pi. So how long to complete one cycle? John, how long to complete one cycle? So think, wait. Think about it. 2 pi is the same as 360. Do it in degrees.
You said 2 pi divided by 360?
No. 2 pi is the same as 360. So if you completed 1 normally in 360, now you have to complete 3 in 360. So how long to complete 1? Yeah, so how did you do that? You said
360
divided by 3. So the same thing. There's your period. So every 120 degrees, think in degrees if you have to. Every 120. Now, every 120, I need to go through my whole unit circle, which has 4 quadrants. So what is 120 divided by 4?
40. Probably not 30.
30, okay? So every 30 degrees, I need a quadrant. So here I am at 90. As a matter of fact, yours incremented by 30. So you're incremented here by 30s. So watch. 30, 60, 90, 120. There's 1. Do it again. 30, 60, 90, 120. There's 2. 30, 60, 90, 120. There's 3. I have trouble with that one too. 2 pi over 3 doesn't really help me out too much.
Yeah.
But think in degrees when you have to do your frequencies. A regular pi is not so bad. But when you start breaking it down into 45s, and even 45s are kind of nice because they're half of your 90s. But if you have to break it down into 30s, into 60s, into 45s, break it down that way. And now, here's your cycle. My cosine said 1, 0, negative 1, 0, 1. Did I change the amplitude at all?
No.
No. But what does this plus 1 mean?
It's a vertical shift.
It's a vertical shift. So watch. I'm going to add 1 to everybody. Do it right here. So here's my cycle. 2, 1, 0, 1, 2. So I start right here. 2, 1, my tick marks are off. 1, 0, 1, 2. So here's my first one. Do it again. 2, 1, 0, 1, 2. There's my second one. I don't even have to think about it. 2, 1, 0, 1, 2. There's your third one. Use your cycles. You have to go through 4 quadrants. If you put this in your calculator, did anybody try putting it in their calculator?
Yeah.
Okay, we're gonna come back to this one. Let's come back to this one in a second. I want to go through these other ones, and we're gonna come back and put that in your calculator. And you're gonna have to think through this in order to get it in your calculator. So this guy had a phase shift where? To the left. So I went left half units. So,
It could still, you could go either way, couldn't you? Because
well, technically I went left. My cycle technically starts from negative pi. Did I change my frequency?
No.
No. So technically I'm going negative pi to pi. This is where my first cycle supposedly starts. Now we kind of talked about this. This goes on and on and on. Like Ashley said, technically, could you go a different way? It's a continuous cycle. But technically, my one full cycle goes from negative pi to positive pi.
Yeah, I was saying, like, if you shifted to the right, it would be the same thing.
In this case, yeah, because your period is 2 pi. Yeah, so you're ending here and starting here, because your period is 2 pi. Because we didn't change your frequency. So I have to go here. So here's my negative pi over here. So here's my, did I do anything else? No. So here's my 0, my 1, my 0, my negative 1, my 0, my 1, my 0, my negative 1. Okay? Or start here. Start here and do your cycle and then just walk backwards. And it's very hard to see a shift. If I gave you, said, write me the formula for this, write me the equation for this. If I asked you what this sign, this curve is,
It could just be a negative sign.
it could be a what? It could be a negative sign. So how could you write this? A reflection. Couldn't this also be a reflection? Right? Because aren't I going the same way? 0, negative 1, 0, 1, 0.
They would have to tell you.
I would have to tell you. Give me a phase shift, or just give me, that's why when it comes to finding equations, you can get more than one equation. I could also make this a cosine curve and shift it. Can I? Can I start here and shift it with a cosine curve?
Yeah.
Yeah, I can do anything I want to that. Did I
Then
have
you
a
could start
question?
at pi over 2 and make it a negative cosine.
And make it a negative cosine curve, right here, absolutely. So you can do a lot with these, because the fact that they're continuous curves. Questions?
Yeah.
Go ahead.
For number 9,
Yeah,
why did you, like, on the
we didn't reflect it. Your period went from, your cycle went from negative pi to positive pi. So negative pi is over here. So it did start at negative pi to positive pi. At positive pi, it starts another cycle. So if it helps you, start at positive pi, 1, 0, negative 1, 0. Just walk yourself backwards on this. Just go backwards. Start here, but then walk yourself backwards. That's what you shifted. Because they only gave you from 0 to 2 pi, so you couldn't go to the negative side. That's a disadvantage of going from 0 to 2 pi. You can't see that it technically starts at negative pi. And when we say technically starts, that's what we consider a full cycle. Yes, this is an endless curve, but we consider that your full cycle. Now, your last two. It's got a lot going on here. This is a sine curve. it's got a frequency of 2. What does that tell me?
So there's gonna be 2 cycles.
2 cycles. So 2 cycles in 2 pi. How long to complete 1? Pi. So every pi, I need to make a cycle. So right away, I'm going to do this. I'm going to just get ready to, excuse me, go through my 4 quadrants. Now, my sine curve says 0, 1, 0, negative 1, 0. What's this 2 doing?
Amplifying.
Amplifying it. So what should I do to all those zeros, ones, and zeros? Multiply them by 2. So if I multiply by 2, I get 0, 2, 0, negative 2, 0. What's this negative 1 doing? Vertical shift down. So what's going to happen to all these points? Where are they going to go? Subtract 1. So I get negative 1, 1, negative 1, negative 3, negative, oops, I must be off somewhere. Subtract 1. So negative 1, 1, negative 1, negative 3, negative 1. Now, there's your pattern. Look, negative 1. Go by your tick marks. 1, negative 1, negative 3. See it? Negative 1. There's my first cycle. Excuse me. Just follow your cycles. Your cycle is not changing. You're still going through 4 quadrants every time you do this. You're always looking for your maximums and your minimums and your zeros. And where do you find your maximums, your minimums, and your zeros and your unitaries? At your quadrant angles, right? Aren't those where my ones and my zeros are? So it's my maximum and my minimum. So I'm always walking through those same numbers. Now this one's got a little bit more going on. This one says what? Well, what's my frequency here?
Or 1.
1. So luckily that doesn't change. My frequency is 1. So I'm still going to do my regular cycle of sine. My 0, 1, 0, negative 1, 0 into pi. However, I shifted. My shift says go from pi. It's going to start at pi and it's going to go, where's one full cycle going to give me? Pi to where? If a full cycle is 2 pi and I start at pi, where am I going to end up? 3 pi. What's this 2 doing to me? Amplifying. So take all of these, multiply it by 2. 0, 2, 0, negative 2, 0. What's this doing? Base, that's just a vertical shift. Where? Up 1. So add 1. 1, 3, 1, negative 1, 1. Right? Okay, so now, start at pi. Here's pi. Just start at pi. That's where your cycle starts. So I'm 1. I didn't change my frequency. Then 1. Then I'm 3. Then I'm 1. Then I'm negative 1. Then I'm 1. So technically, here's my first cycle. But I need to go backwards. So just go backwards from here. So keep going backwards until you get to, it's very symmetric, this curve. Just keep going backwards until you get to the end of your graph part. To your window frame. Well, a window frame.